Welcome back, developers. In today's video, we're diving deep into the anatomy of a Spring Boot application. Understanding its structure is crucial for mastering Spring Boot. Let's embark on this journey together and unravel the magic behind the scenes. Every Spring Boot project follows a specific structure, designed for ease of development and understanding. At its core, the structure divides the project into several key directories and files, each serving a distinct purpose. First, we have our src/main/java directory, home to our application's heart and soul, our Java code. This is where you'll spend most of your development time, crafting the logic that powers your application. Central to our application is the main application class. Annotated with its Spring Boot application, this class serves as the launching point for our Spring Boot application. It's here that we kick off our application's lifecycle, courtesy of Spring Boot's auto-configuration magic. At Spring Boot application is a meta-annotation that encompasses three critical annotations at Spring Boot configuration, at enable auto-configuration, and at component scan. Spring Boot examines your class path, checks for specific classes, and automatically sets up configurations based on what it finds. From setting up a web server to configuring a database, auto-configuration covers a lot of ground. In more detail about auto-configuration, we will discuss in a separate video. Next up is the src/main/resources directory. This vital directory houses our application's properties files, like application.properties or application.yml, where we configure our application's behavior. It's also where our static and templates folders reside, containing our static assets and view templates, respectively. Moving forward, let's shift our focus on application properties. Configuration in Spring Boot is both powerful and flexible, thanks to the application.properties or application.yml files. Here, we can tailor our application, setting everything from server ports to database connections, all in a straightforward and easily accessible manner. By default, Spring Boot will load properties from a designated file named application.properties or application.yml. This file holds special significance for Spring Boot, as it is automatically recognized and searched for within the src/main/resources directory. Suppose you want to run your Spring application on a port other than 8080. You can configure this by specifying server.port in your application.properties. Simply enter the desired port, such as 8090, and start your application. Voila! Spring Boot will then start your application on port 8090. Here you see in logs Tomcat server is running on 8090. You can verify this by checking if the application is indeed running on port 8090. Let's verify it. In the last tutorial, we created our first REST API. Type localhost 8090/hello in your browser's address bar and press enter. Wow! It's returning the expected response. This indicates that our application is running on port 8090. In application.properties, you can also configure your custom properties. So I could say youtube.favorite.channel equals gandarpun. youtube.favorite.channel.url equals https://www.youtube.com/@gyandarpan22, and so on. So you can give as many properties here as you'd like in this application.properties file. Now, how would you go about reading data from the application properties? So, we know it's under source/main/resources, and I put my own custom properties here. Now, I want to retrieve my favorite YouTube channel and its URL within our REST controller code. It's simple. Spring makes these tasks easy by injecting our custom values into the required variables in Java code. Spring provides the @value annotation for this purpose. Simply add this annotation above the variable where you want these values. In my REST controller, I inject our favorite channel value into our variable by adding the @value annotation. Inside it, type $youtube.favorite.channel. This tells Spring Boot to inject the value from the favorite.channel key in the application.properties file into this variable. Let's create another REST API inside our myREST controller and return our favorite YouTube channel and its URL. Okay, now start our application. Now, type our REST API URL in the browser, which is localhost 8090/custom/values. Wow, it's like magic! It's working perfectly and returning the value present in our properties file. Now onward, I will be using application.yml instead of application.properties. I prefer application.yml. If you want to use application.yml as well, rename the application.properties file as application.yml. You can use either one of them as you like. Inside the resource folder, you will also see the static and template folders. Static folder typically contains static resources such as CSS files, JavaScript files, images, and other assets that are served directly to the client without any processing. These resources are typically used to style and enhance the user interface of the web application. Template folder usually contains templates for generating dynamic content in the web application. These templates are often written in a templating language such as Timeleaf, FreeMarker, or Mustache. They allow for the dynamic generation of HTML content based on data from the server, which can then be rendered and displayed to the user. In the last Maven project structure video, you will notice that the web app folder is present inside the resource folder. However, it is missing here. In our pom.xml, we specified the packaging as jar. A jar file does not require this folder. This folder is typically used for WAR files. Testing is paramount in software development, and Spring Boot places tests at your fingertips in the src/test/java directory. Here, you'll write tests to ensure your application behaves as expected, bolstering your code's reliability and robustness. Okay, now move to our pom.xml. In the last video, I already explained everything about the pom.xml. If you missed it, please watch those videos first. Dependencies are the building blocks of our application, and Spring Boot makes managing them a breeze with its starters. These starters, defined in our pom.xml file, bundle together common dependencies, streamlining our project setup. In simple word, it is a collection of Maven dependencies. Inside the dependencies section, you will find the Spring Boot Starter Web dependency. The Spring Boot Starter Web is one of the most popular starters provided by Spring Boot, designed to simplify the bootstrap process of creating web applications and RESTful services. It includes all the necessary dependencies to start developing web applications with Spring MVC. By using this starter, you can quickly set up a Spring-based application that's ready to serve HTTP requests. You will also see Spring Boot Starter Test inside the Dependencies section. The Spring Boot Starter Test is a crucial starter provided by Spring Boot, tailored for simplifying the testing of Spring Boot applications. It bundles together several libraries essential for testing, ensuring that developers have a comprehensive and integrated environment ready for a variety of test scenarios, from unit tests to integration tests. Spring Boot provides a variety of starters. If you want to explore all Spring projects, you can visit the official Spring website, https://spring.io. Now, let's move to the Build section. Inside the Build section, you will find the Spring Boot Maven plugin. The Spring Boot Maven plugin is a powerful tool provided by Spring Boot that simplifies the process of building and running Spring Boot applications with Apache Maven, a popular project management and comprehension tool. This plugin provides several goals to work with a Spring Boot application, including running, packaging, and creating an executable jar, among others. Allows you to quickly compile and run your Spring Boot application using the Spring Boot Run goal. So far, we've been using the IntelliJ Run option to run Spring Boot. If we need to run it from the terminal, we can simply use Spring Boot Run. This will start our application in the same way. You will also find mvnw and mvnw.cmd in the Spring Boot project. MVNW stands for Maven Wrapper, an excellent tool that allows users to run Maven commands without having Maven installed and configured on their system. It aims to provide a simple way to ensure a user of your project has everything necessary to run your Maven build without needing to install Maven beforehand. This is particularly useful for ensuring consistency across development environments and CI/CD pipelines. The Maven wrapper is essentially a set of scripts and a small jar file that bootstrap the Maven build process. If Maven is not installed on your system, then when you run the mvnw command, it automatically installs Maven require version on your system. When you run mvnw on Unix-like systems or mvnw.cmd on Windows for the first time, it downloads the specified version of Maven as configured in your project and uses it to execute the build. This means that regardless of whether the user has Maven installed or which version they have, the build will always use the version of Maven specified by the wrapper. With our application structured and configured, running it is as simple as executing a command. This seamless integration between components is what makes Spring Boot a powerful and preferred choice for developers worldwide. And there you have it, a comprehensive exploration of the Spring Boot application structure. Armed with this knowledge, you're well equipped to navigate and harness the full potential of Spring Boot in your projects. Happy coding, and see you in the next tutorial. Don't forget to like, subscribe, and hit the notification bell to stay updated with our latest tutorials. Share your thoughts and questions in the comments below. Until next time, keep learning and keep coding.